I want to start today's deep dive by invoking a very specific memory. And I think if you went to school any time in the last, say, 50 years, you probably know exactly what I'm talking about.
Oh, I have a feeling I know where this is going.
Right, so it's the geography lesson. You walk into the classroom, and there is this massive, heavy cylinder hanging right above the chalkboard.
Yes.
The teacher grabs that little metal ring at the bottom, gives it a sharp tug, and snap down comes the whole world.
The classic pull-down map, usually a Mercator projection, probably slightly yellowed at the edges, maybe a little tear right down in the corner by the Pacific Ocean.
Exactly. And it was very distinct. It was a physical object in the room. I mean, it literally smelled like vinyl and dust. But I think more importantly, it was absolute.
It was static.
Right. It was a snapshot of the world, completely frozen in time. Borders were locked in place. Cities were just dots, and that was it. You memorized the dots, you took the quiz, and then the map just snapped right back up into the ceiling.
Yeah, because it was purely a reference tool. It was designed to answer exactly one question, which is, where is X?
Right.
It really wasn't designed to ask why or how or any of the deeper questions.
And that really is the pivot point for today's deep dive. We are looking at a stack of source materials regarding National Geographic MapMaker. And if you're listening to this and thinking, oh, great, they just digitized the old wall map, you are vastly underestimating what is actually happening here. This isn't just about throwing a map on a screen. It's about a fundamental shift in how we expect the next generation to actually understand the planet.
Yeah, if the old wall map was a painting, MapMaker is an engine. It's a completely different category. We're moving from static geography, memorizing capitals and rivers, to what the source material repeatedly calls spatial thinking.
Spatial thinking.
Exactly. And that shift is massive because it turns the student from a passive observer into an active problem solver.
Okay, spatial thinking. It's a term that pops up a lot in the documentation we have today. And it sounds, I don't know, a bit academic, maybe even a little buzzword heavy. What does that actually mean in this context? Because, I know where my house is. I know where the grocery store is. Does that make me a spatial thinker?
I mean, to a degree, sure.
Mm-hmm.
But in an educational context, spatial thinking is the ability to visualize and interpret data through the lens of location.
Okay.
It's understanding that where something is might actually be the most important variable in understanding what it is. The documentation breaks this down into a framework of 3 specific questions. And honestly, for anyone listening, if you take nothing else away from this deep dive, remember these 3 questions. They form the entire scaffolding for this kind of critical thinking.
I saw these in the notes. They seem deceptively simple. The first one is literally just what's where.
Right, what's where.
Okay.
That is your identification phase. That's the old pull-down map.
Right.
There is the Amazon rainforest. There's the Sahara Desert. It's just the baseline data.
Okay, but then we immediately jump to question 2, which is why there?
And this is exactly where the brain has to actually turn on. Why there? Why is the Amazon rainforest where it is? Why isn't it in Kansas?
Right.
Now you have to start looking at climate patterns, the equator, Hadley cells, the flow of moisture from the Atlantic. You aren't just pointing at a dot anymore. You're diagnosing a system.
Diagnosing. I like that. And then there's the third question, which I think is really the clincher here.
Yeah.
What does it mean?
The so what question. This is synthesis. Okay, so we know the Amazon is here. That's the what. And we know it's because of these specific climate conditions. That's the why. So what does it mean if we cut it all down?
Oh, wow.
What does it mean for the global carbon cycle? What does it mean for the indigenous populations living there? Suddenly, your standard geography lesson becomes a lesson in economics, ethics, climatology, all of it.
It forces you to connect the dot to the actual consequence.
Precisely. And that is what MapMaker is built to facilitate from the ground up. It's not just designed to show you the world, it's designed to help you solve it. The source material explicitly frames their mission as empowering the next generation of problem solvers.
Which is a pretty lofty goal for a piece of software, right? So let's look under the hood a bit. How does it actually do that? Because I could ask why there while looking at a paper map, technically.
You could, but it's really hard to verify your hunches with a paper map. The real power of MapMaker lies in something called layers.
Layers. Now, back in the day, I remember teachers sometimes had those clear transparency sheets they'd lay over a map on an overhead projector. Is that essentially what we're talking about?
Conceptually, yes, it's the same idea. But in terms of fidelity, We are light years beyond transparency sheets. We're talking about geospatial information systems, or GIS. This allows you to stack completely different massive data sets on top of each other to reveal patterns that are completely invisible to the naked eye.
Give me a concrete example of that. How would a student actually use these layers in a classroom?
Okay, let's stick with the problem solver theme. Imagine you're a student and you're looking at a map of a region experiencing heavy conflict. On a standard map, you just see borders, maybe some cities, maybe topography.
Just the basics.
Right. But with MapMaker, you can go in and toggle a layer for drought history.
Okay, so now you see rainfall patterns.
Exactly. Then you toggle another layer for population density, and then maybe a third layer for agricultural yield. Suddenly, you see a direct correlation. You see that the conflict isn't just random political violence. It's happening exactly in the spots where the water ran out and the population spiked.
Oh, wow. So you're seeing the stress
You're
points.
seeing the causality. You are discovering for yourself that the war is actually a resource war. And that is a realization that you just cannot get by reading a textbook chapter that simply says there is conflict in region X. When you layer that data yourself, you own that insight.
That brings up a really interesting point about the data itself, actually. The source material mentions that this isn't just, random internet data scraped from Wikipedia. It's carefully curated and inspired by National Geographic explorers.
This is a crucial distinction. We live in an era of total data overload. I mean, you can find a map online right now that proves the Earth is flat if you look hard enough.
Yeah, very true.
But
Yep.
MapMaker provides this walled garden of verified high-quality data. When they say explorer-inspired, they mean it models the actual methodology of scientists working out in the field.
How so? Like, what does that practically mean for the software?
Well, think about what a National Geographic explorer actually does. They don't just wander around the jungle hoping to find something cool. They go in with a hypothesis. They look for the intersection of distinct variables, like, say, human footprint versus biodiversity. MapMaker gives students access to those exact same variables that these professionals use.
Which perfectly brings us to a name that appears frequently in the source material. And I think we really need to pause on it because it entirely changes the weight of this conversation. Esri.
Yes.
Esri.
For the uninitiated listener, who or what is ESRI? Because to me, it just sounds like a corporate acronym.
It stands for Environmental Systems Research Institute, but honestly, that doesn't even begin to capture their scope. Esri is the absolute giant of the GIS world. They build the software that literally runs the modern world's infrastructure.
Give us a sense of scale here. How big are we talking?
When FEMA is tracking a hurricane's path to decide exactly where to stage relief supplies, they're likely using Esri software. When the CDC was tracking the spread of COVID-19 and mapping outbreak clusters, that was Esri. Urban planners deciding where to put a new subway line to maximize ridership. Esri?
So when a student opens MapMaker, and we'll get to how they access it in a second, they aren't just using some watered-down kiddie version of a map. They are essentially using the engine that governments use. It's the exact same underlying logic and technology, just presented with a simplified interface. And I think this is a massive point that often gets overlooked in EdTech. We aren't just teaching kids geography here. We are training them on professional-grade tools.
Right.
It's the difference between teaching a kid to draw with crayons versus teaching them to use a simplified version of AutoCAD. One is play, but the other is actual pre-professional training.
That is a wild thought. You could have a 12-year-old doing a Tuesday afternoon project on climate change using the exact same data visualization engine that a climate scientist might use to brief a senator.
Exactly. It completely blurs the line between student and researcher at a very early age.
But professional software usually comes with two massive headaches. First, it's usually incredibly expensive. And second, it usually has a terrifying learning curve.
Right, the barriers to entry.
Exactly. And this is where the source material makes a really big deal out of their no-friction design.
Yes, no friction is absolutely the goal here. And they attack this from a few different angles. The first, and arguably the most obvious, is the cost. MapMaker is free.
Which is fantastic, obviously. Budgets are always tight. But the second one, which the sources really highlight, is the no login requirement. Now, to the average person, that just sounds like a nice convenience. Oh, good, one less password to manage. But in a school setting, that's actually much bigger, isn't it?
Oh, it's an equity issue. Absolutely. Think about an under-resourced classroom for a second. Maybe they don't have one-to-one devices for every kid. Maybe they have a rolling cart of 5-year-old tablets that are shared between 3 different grades.
Right.
If a teacher has to spend the first 20 minutes of a 40-minute period just getting 30 chaotic kids
Hmm.
to remember their specific usernames and then resetting passwords for the 5 who forgot them, the lesson is basically over before it begins.
It totally kills the momentum.
It kills the learning entirely. By making it a no-login system, they are essentially making a statement. They're saying that access to high-quality geospatial data should be as easy as simply opening a book. You don't need a login to look at the pull-down map on the wall. You shouldn't need a login to look at the digital twin of the Earth.
And speaking of those older school devices, the lightweight aspect is mentioned in the sources too. It runs on tablets, laptops, Chromebooks.
Again, this goes back to reality versus fantasy. In a fantasy world, every student has a high-powered gaming PC to render 3D maps. In reality, most public schools are running on older Chromebooks that struggle if you have too many browser tabs open.
Definitely.
If MapMaker required a heavy software install or massive processing power, it would be completely useless to the schools that need it the absolute most. By making it browser-based and lightweight, they truly democratize the access to the tool.
So we've got the philosophy down and we understand the engine. Let's talk about the user experience, because you mentioned earlier that the old maps were static, but MapMaker allows for both 2D and 3D exploration. Is that just a cool factor to keep kids engaged, or does it actually change the analysis?
No, it's fundamental to accuracy. We are so used to seeing the world in 2D, usually through that Mercator projection we talked about, the one where Greenland looks like it's the size of Africa.
Right, the classic rectangle map.
Exactly. That projection heavily distorts reality. It distorts both size and distance, especially as you get near to the poles. When you switch MapMaker to 3D mode to a true globe view, you finally see the true spatial relationships between continents.
How so?
Well, you see that the shortest distance between the US and Russia is actually straight over the Arctic, not across the map from left to right.
Mm.
And that entirely changes how you understand geopolitics, missile ranges, global flight paths, and especially weather systems.
And then there's this ability to sketch. The source material points out that you can draw directly onto the map itself.
Yes. Sketching is kind of a humble word for what is actually deep annotation. When a student draws a circle around a specific area, or when they trace the path of a river, they are actively claiming that data. They are telling the viewer, I am focusing right here. It allows them to layer their own personal observations directly on top of the professional datasets.
It almost feels like that connects back to the whole explorer identity. You aren't just passively looking at the territory anymore. You're marking it like the old map saying, here be dragons, but in this case, it's more like, here be the high nitrate levels.
That's a great way to put it. And that leads directly into the workflow integration. The sources really emphasize that students can easily save these maps as images or export them as PDFs.
Which sounds pretty basic, honestly.
It sounds mundane, yes, but think about the output. Instead of writing a standard Word document paper where they just type the population is high near the coast, they can actually generate a custom map, complete with their own sketches and data layers that visually prove the population is high near the coast.
Ah, I see. It turns the map into actual evidence.
Exactly. It turns the student into the authority on the subject. They created the visual artifact that supports their own argument.
Now, I want to play devil's advocate for just a second here. This all sounds fantastic for the students, but I'm imagining a teacher who has been teaching social studies for 20 years. They know their textbook inside and out. They know their trusty wall map. And suddenly, they are handed this professional-grade GIS tool and told, okay, go teach spatial thinking. That has to be terrifying.
Oh, it is. Tech fatigue in education is very real. And the fear of looking incompetent in front of a room full of digital native students is a very real anxiety for teachers.
So what does the support ecosystem look like for them? Are National Geographic and Esri just throwing these teachers into the deep end and hoping they swim?
Not at all. And I think this is where the partnership between National Geographic and Esri really shows its maturity. They've built an entire scaffold around the tool. The source material lists a whole suite of resources, starting with these classroom activities that are short and standards-based.
Standards-based. That is the magic word for any teacher.
It really is. It translates to, this will actually help your students pass the required curriculum. They aren't asking teachers to invent an entirely new course from scratch. They're basically saying, hey, are you already teaching a unit on tectonic plates? Here is a pre-made 10-minute activity using MapMaker that shows the Ring of Fire way better than your 20-year-old textbook does.
So it's highly modular. You can just dip your toe in if you want.
Exactly. It's very low pressure. And for the teachers who do want to dive deeper, there are skill-building videos and detailed tutorials.
Mhm.
But that low floor, high ceiling approach is really the key to adoption here. You can use it for 5 minutes to show one specific thing, or you can build an entire semester-long capstone project around it.
The sources also mention the Esri education team and newsletters. It seems like they are trying to build a real community, not just a standard IT help desk.
They are. They're trying to build a cohort of educators who are genuinely comfortable with geospatial technology because, again, if you look forward 10 or 20 years, these specific skills, data literacy, spatial analysis, the ability to understand complex interconnected systems, these are exactly the skills the job market is going to demand.
It's interesting you mentioned the job market. We talked about empowering problem solvers earlier in the deep dive. But when you look at the really big problems we're facing today, things like climate change, rapid urbanization, global resource management, these are all fundamentally spatial problems.
They are entirely spatial. You can't solve a global pandemic without a map. You can't solve a regional water crisis without a map. Location is everything.
So by introducing this tool into classrooms now, we are essentially upgrading the operating system of the next generation of thinkers.
That's spot on. We are moving them away from a worldview that is fragmented and static. Here is a country and here's a resource, to a worldview that is highly interconnected and dynamic. Here's a system. And once you can actually see the world as a functioning system, you can start to figure out how to fix it.
I want to circle back to that idea of friction one last time before we finish up. We talked about technical friction earlier, things like logins and loading times. But there's also cognitive friction, right? Just the sheer difficulty of trying to understand a massively complex idea.
Right.
It seems to me like MapMaker is fundamentally trying to reduce the cognitive friction of understanding global scale.
That's a brilliant way to put it. The human brain isn't really wired to natively understand planetary scale. It's simply too big. We deal in neighborhoods and towns. But by giving a student the power to smoothly zoom all the way in from outer space down to a street corner, and then to layer invisible data like average temperature or median income over that visible physical terrain, you are taking the abstract and making it incredibly concrete.
You make the invisible visible.
And when you make it visible, you make it actionable.
So let's wrap this up. We've gone from the dusty, static pull-down map to a free, browser-based, professional-grade analysis engine. We've seen how it completely shifts the educational question from where is it to what does it mean? And we've looked at how it aggressively removes the barriers, cost, logins, hardware limitations that usually keep these powerful tools out of the hands of the kids who might need them the most.
It's a true democratization of the Explorer's Toolkit.
To you, the listener joining us for this deep dive, maybe you're a teacher, maybe you're a parent, or maybe you're just someone who's fascinated by how we know what we know about our planet. The big takeaway here isn't just about a cool new app that schools are using. It's about a fundamental shift in perspective.
We are training students to look for patterns and relationships, not just isolated facts.
And that leads me to a final thought I really want to leave you with today to sort of mull over. We established that this MapMaker tool uses the exact same data layers as professional scientists. It runs on the exact same logic as the Esri software used by global leaders and emergency responders.
Yes, it does.
So if a 12-year-old sitting in a middle school classroom today can access the exact same data on, say, deforestation as a researcher out in the field, and they have the exact same tools to ask why and what does it mean, are we reaching a point where the classroom isn't just a place where you learn about the world, but a place where you can actually start contributing to the research?
That's the ultimate dream. The traditional barrier between learning about a problem and doing something about it is completely dissolving.
And honestly, if that barrier dissolves, I really wonder what kind of solutions those students are going to find that the experts, with all of their years of experience and inherent biases, might have completely missed.
I think we're going to be very surprised by what they come up with.
I certainly hope so. Thanks for diving in with us today. We'll see you next time.